Alright, so the next topic is Boolean flags and comparing strings. So a Boolean flag, is a Boolean variable that is used to track state in a program. Think of state as like a state of matter, like how H2O can be solid, liquid, or gas, and it can have only one particular state at a time. This is what state is in programming. So we've seen this concept before when we learned about combined assignment operators. So think of like this. Think of this example. So in this example, we have an integer variable called coffee in cup, and it starts off at 90. So you can think of that as like 90% full when you pour your cup of coffee. And then as the program executes, we use these combined assignment operators. In this case, the minus equals assignment operator, which, if you recall, basically stands for this. So it's basically coffee in cup equals coffee in cup minus a big sip. So whatever coffee in cup was right here at 90%, 90 minus whatever big sip is the result. Coffee in cup becomes the result of that. So that's what the combined assignment operator simplifies for us. It says coffee in cup minus equals big sip. So whatever coffee in cup is at that moment, in this case 90, take that and subtract 30 from it. And then the key thing is that if you run that operation again, at the starting point, coffee in cup is 60. And then you subtract 30 from that. So if we look at it like this, we know from line 4 that coffee in cup means that it's 90. And then after this operation, CIC is 60. And then down here, we run the operation again, and coffee in cup is actually 30. And now, of course, we can have other amounts that we subtract by. So if we see that we take a small sip, that's defined as 15. So now in this case, we take whatever the current state of coffee in cup is by line 16, which we know is 30, and then we subtract 15 from that. And so coffee in cup is 15. So if we print this on line 18 as we do here, we'll see that coffee in cup is 15. And now also, of course, there are other combined assignment operators like the plus equals, minus equals, multiplication equals, divide equals, and modulo equals. But the point is the same in each of the cases. If we take whatever coffee in cup is at this moment and we add it, add refill to it, and we define refill as a number with the value of 50. We pour in a 50% refill. Now we basically take 15 and we add 50 to it, and coffee in cup is 65 at this point. So if we print it out again, we see the 15 and then we see the 65. So all of this is just an example of variable state. The state of a variable can change because we can reassign variables. And in Java, the state of a variable is determined by statements that come before it. In many programming languages, it's like that. Now the concept we're about to cover, Boolean flags, works similarly, except they usually just act as tripwires for locking or unlocking additional functionality in your programs later. So for example, if we again had a score variable, a score on a test or something, 72.5. And we also create a Boolean variable called passing score, and by default we set it to false because we don't want to assume that a student has automatically passed. Then we can run a simple if statement with the Boolean expression evaluating whether the score is greater than 59.9. So if a test score is greater than 59.9, that indicates that a student passed. So if that is true, then we can reset or reassign the passing score variable to true. And then later in the program, we can have logic that basically unlocks only if the condition previously is true. So we're kind of building on these different concepts. So we have this first Boolean expression, which we're not sure if it's going to evaluate to true or false. Because if I'm grading someone's test score, for example, and the grade is 58, then I can't set passing score to true. It must remain as false as it is by default. And so let's say you had a final grade and it rounded out to 58. You do not have a passing score. So your passing score Boolean variable is false because this doesn't run. Or this code right here does not execute because score is not greater than 59.9. And therefore, if passing score is false, then this Boolean expression right here evaluates to false, and this line is never run. And in the case of the English language, and we know how school works, sometimes like if you don't get a passing score, you're not eligible to go on to the next course. So if you don't have passing score as true, you cannot move on to the next course. So right now, let's just say that our final score for the class that we got was 85. And so we run this, and it says eligible for the next course. But if we flip it around and say 58, nothing gets output because it's not a passing score. So that is Boolean flags. A common use for Boolean flags is to check whether a user is authorized before you show them content in your app. So as this is a very simple example, but let's say that we had an app or some type of a admin Java application, and we had a Boolean variable called is logged in, and we initially set it to false, and then we have a password, a secret password, and then we have the password that a user enters to try to enter into the administrative area of the app. So what we would do is we would do a check with our if statement, with our Boolean expression. And we would say, if user pass, the password that the user entered in equals the secret password, the actual password to get in, then we can say that the user is logged in, that is true. And then if that is true, if the user is logged in, then later we can validate that, and if that is true, that the user is logged in, then we do whatever we want. We let them in, and we let them, do whatever stuff the admin app can do. This is obviously just a very simple example, but in a more complex case, like with a banking app, we would store usernames with passwords in a secure database, and only after the user proves that they are logged in and that they are who they say they are, then we can return their specific account details, such as their account number, the bank balance, and things like that. And one other thing to note is that in this example here, we use this as a Boolean expression. We say user pass equals secret pass. And you might think that that's a bit strange, because with other types of logins, we validate things using the relational operator. So we say if age equals 21, if we had an int age equals 21, then we say if age is 21, you log in. If grade is A, we say if grade equals A, things like that. But with string, we say if user pass dot equals secret pass. What's that all about? So in this example, user pass is what the user typed in, and then that is a string. And strings have the equal method, as we've talked about. This method takes one input parameter, which must also be a string, and this method equals returns a Boolean. You can see, if you hover over it, you can see right here, this means that it takes a Boolean, or it returns a Boolean, sorry. So this right here is a valid Boolean expression. But the question is, why aren't we writing it like this? If user pass equals secret pass. Well, the reason is because strings are objects, not primitive data types. Primitive data types store the actual value in memory, while objects store a reference in memory. A reference to a memory location where the values and metadata are stored. So because of this, the equals operator compares the memory address of the two strings, not their contents. So sometimes it may appear to work, but it's unreliable. So to compare the actual text content of two strings, you must use the equals string method. Something else that is helpful regarding those string methods, especially the equals method, is that there's an additional method available to strings, which is equals ignore case. So if you had a username which is not case sensitive, and somebody typed in the same username but with a lowercase, you can use the equals ignore case method, and they will return as this Boolean expression, I should say, will return as true. Yes, so this returns usernames are the same, ignoring case. However, if I just ran if username equals username2, nothing prints out. So while with strings, we don't use the equals operator. We have methods available to us to achieve the same functionality.